And now since material properties has been assigned, we need to create a load collector because we need to apply load onto this plate. So I click on this option of load collector, click on load collector, go to the option of create. In the load collector name, first name we need to insert, that is SPC. SPC means single point constraint. Give it some different color. Give it color like this. No card image and click on create. And then we need to create one more load collector, that is for force. So once again load collector name, I insert the name force. Give it some different color like this and click on create. So now we had created two load collector. I can go to this model tree, we have load collector. Click on this plus symbol, we have SPC and force. I click on this SPC, right click and click on make current. And suppose I selected top view. So select this XY view from here. And then I go to analysis, click on this constraints. So now we are going to apply constraint to this. As we know in the problem, left and right side of the geometry is fixed. So we are going to apply that constraint to this. So just select the nodes. In this type, select the nodes, hold down the shift key and drag a rectangle. Hold down the shift key and hold down the left click of the mouse. And now we can see a rectangle is creating. Just select only the corner nodes. Select all the nodes and we can see all the nodes are selected. Once again we need to select this node onto this right side. So hold down the shift key, hold down the left click and drag a rectangle like this. Make sure only outer nodes are selected. And now we can see all the nodes are selected. And now since our geometry is fixed on the both sides, so make a check on this all the degree of freedom. We don't want any motion in any direction. Insert all the values 0 and click on create. Go to return. Rotate the model. I zoom in and we can see constraint has been applied. And now we have to apply the force. So select this top view once again. Go to analysis. So before this, go to this force option. Make a right click on this and click on make current. So all the properties will go to now force. Click on this force option. Go to nodes. So as we already know, we had created 40 nodes at the boundary of this hole. So we need to divide this force by this 40 because the force is distributed across this boundary. So 1000 is divided by 40, so we will get the value 25. So each node has a load of 25. So select the nodes. So we need to select the nodes onto this boundary. So select all the nodes one by one. So nodes are selected. I go to magnitude. As we had discussed, the value of this magnitude on each node will be 25. So I insert the value 25. Press enter. And now we have to specify the direction. For the direction we have some options like X, Y, Z axis, vector, N1, N2. And now we have to find out what is the direction. So I rotate this model. And now we can see the Z direction is going upward. And the force we have applied, that is downward in the Z direction. So in this direction I will select Z axis, and for the downward force I will insert the negative value of force. So I insert the value, that is negative 25. So once again I insert this value, that is negative 25, and press enter. And then click on create. I zoom in onto this. And we can see the force is applied into the downward direction of value 25. So when we sum up all the forces, its total value will be 1000 Newton. So now click on the return. So force and constraints are applied, and now we have to create a load step. So go to analysis and click on this load step, and we need to select what type of analysis we want. In the type of analysis, click on this arrow and select linear static. Give it the name. Suppose I give this name like linear analysis. Make a check on this SPC and load, and then click on this equal option. Click on this equal and select SPC from here. Click on this SPC, and once again for the load, make a check on this load. Click on equal and select force into this. So we have assigned the force and constraint to this load step, and click on create and click on return. And now we have performed all the steps of the pre-processing. So we are going to save this model. Go to files, click on save as, specify a location for this, give it some name and click on save. And then I go to the option of analysis, go to OptiStruct. In this OptiStruct we can see the location of the file. In the type of export, click on this arrow, select all. In the run option, select analysis. In the memory, select memory default and click on OptiStruct. So this problem will be solved by OptiStruct software, that is a solver. It may take some time. So now this window specifying that analysis is completed, and I click on this option of result. So result will be viewed on the Hyperview software, that is called post processing. So a second window has been opened, that is for Hyperview. We have to make sure the location of file is correct and click on this apply, click yes. And now we have to find out the value of stresses. To find out these values, I go to this option of contour, click on this contour. In this we have two options, displacement and elemental stresses. So first of all I want to find out stresses, so click on this element stresses. In the type of stresses I select von Mises stress. The component is this component selected and click on this apply. And now we can see the stresses. This red zone is highlighting the maximum stress. It is specifying the places where the stress will be maximum. So stress will be maximum onto this boundary and onto this boundary. The value of maximum stress will be 7.132 megapascal. So this value of maximum stress is far below the yield stress of the steel, that is 250 megapascal. We can say that this plate is safe and it will not break down under this load. And we will also want to find out the displacement or deformation. So I go to this result type, click on this arrow and select displacement. In this type select magnitude, and displacement will be with respect to Z axis, the vertical displacement. So select Z axis and click on apply. And now we can see the displacement will be maximum onto this outer side, and the displacement is going negative onto this blue region. You can see the displacement is 0 to this red region. It is going negative. So the maximum value of deformation is going, that is negative. So that is 0.288. So this is the maximum value. So if we want any animation, make a click on this start and pause animation. Okay, it is not looking very fine. So I go to the option of deformed, click on this deformed. Result type I want displacement, and I want a scale factor. Type is uniform, and suppose the scale factor I want, that is 100. Press enter and click on apply, and then play this animation. And now we can have a better view. Once again I make a pause onto this. Pick this second arrow and drag it to the leftward. It will slow down this animation. And now once again play this. And now we can have a better preview that how this material is going to behave. So deformation will be like this. Now it is deforming in downward. And let's go to some another view. Suppose I select this ZX view. Click on the ZX view, and now this view will represent a better view of deformation. Now we can see the displacement into this plate. So I click on this XYZ view, and now we can save this. Go to file and we can save this session. So in this way we can perform the analysis in Hypermesh.